Black holes are truly fascinating, massive space monsters that swallow everything around them. But I've got sad news for you. Black holes can die. And since we're talking about surprising facts, empty space isn't actually empty. Here's why. Imagine the universe is like water. Particles are like smooth waves on its surface. This is called the quantum field. Can you imagine what would happen if you put a particle of matter and a particle of antimatter in that field? Well, if you thought this, you got it right. That's right, because they're opposite, they destroy each other super fast. But not with the explosion and not with the amazing soundtrack. Because these particles disappear so quickly, they're called virtual particles. So empty space isn't actually empty because it is packed with these particles that keep popping in and out of existence. But near a black hole, things change. Think of the following scenario. The black hole is a giant, massive cookie. It has an event horizon, a place where gravity becomes so strong nothing can escape anymore. It's like you're swimming near a whirlpool. There's a point where you can still swim away, but once you get too close to the center, the water simply pulls you in no matter how much you fight. Near that region, a pair of virtual particles is formed, one with positive and the other with negative mass. The positive mass particle is just a normal chocolate chip. The negative mass particle, on the other hand, is a vicious cookie eater. What happens is that near a black hole, the quantum field is so unstable that these particles can actually split up. The negative mass particle goes inside and eats the cookie. The positive mass particle, however, escapes and becomes a real particle. When it does so, it produces a glow. This glow is called Hawking radiation, named after British scientist Stephen Hawking. This effect means that a black hole shrinks down over the years as negative mass eats it up and the chocolate chips fly away through Hawking radiation. But that's when the paradox arises. The thing is, everything the black hole swallows is information. So if the black hole dies, information dies with it. However, that's against the laws of physics that say information can ever be destroyed. That's called the black hole paradox. Hawking radiation seems to be contradicting physics. Even Hawking's argument is that it doesn't make a difference because once the information is swallowed up by the black hole, it gets mixed up. For example, if I burn this pink piece of paper and this orange piece of paper, can you tell the ashes from each other? He said that's the same for black holes. You can tell if it has eaten a star, a planet, or any celestial object. So even if you had information, you wouldn't be able to do anything with it. That's why it doesn't matter if it dies or not. But after years of the so-called black hole war, Hawking gave in and theorized that maybe, before the information crossed the event horizon, it left an imprint, like a footstep, that allowed us to identify it so that the information wouldn't be lost. But the truth is, this is just a hypothesis. For now, black holes and whatever happens with their information is a mystery.